let's see what do we have here. Here the question is find the moment of inertia of a given uniform rod of mass m and length l about an axis which is at angle theta to it as shown. So first of all, this is not any of the case we know. So far we know the moment of inertia of a uniform rod when the axis goes along the center of the mass of the rod or along one end of the rod, but this is not any of the cases. So we have to go in the trivial method to find out actually what is trivial method. Trivial method is the method in which we have evaluated all the moment of inertias of uniform bodies given in our textbook. So in trivial method we take a differential portion of the given object and we find the moment of inertia of the differential portion, then we integrate it in suitable limit. So first of all, here let's think the differential portion we are considering here is this red one, and let's say the length here is dl, the length of the differential portion, and this differential portion is, and from this end of rod the differential portion is at a distance of say l, and from the given axis about which we have to evaluate the moment of inertia, the differential portion is at a perpendicular distance of x from that axis, and from trigonometry that is totally obvious that x is L sine theta. So first what we do, first we find the moment of inertia of this differential portion, and here di is the mass of this differential portion dm multiplied by the perpendicular distance of this differential portion to the axis which is x square, and plugging in the expression of x we will get L square sine square theta. And what is dm? Dm is mass of the differential portion having a length of dl. So dm will be mass of unit length of this rod. What is it? It will be m by l, because m is the total mass and l is the total length. So if we divide m by l, we will get the mass of unit length of this rod, and we have to multiply it by dl, because you know in unitary system if the mass of unit length is m by l, then the mass of dl length will be m by l into dl, and so we will find this m by l sine square theta l square dl. Now to evaluate the moment of inertia of the entire rod about this particular axis, we have to integrate this. So here's the fun part. First see, along the entire rod theta is constant, right? Theta is same everywhere, so sine theta will be same everywhere. So in this particular case sine theta is constant, so we can take it out of the integral. So let's do it. So I will be integration of di, and here for a particular rod m is constant, l is constant, and we just have discussed sine theta is constant for this particular case. So m by l sine square theta, they all will go outside the integral, and now we have to pick two suitable limits. So let's see here at this end l is 0, because let's see l is the distance of the differential area from this end, and here l is l because capital L is the length of the entire uniform rod. So we have here from 0 to capital L, that is m by l sine square theta, and if we and after integration we will have l cube by 3, and we have to plug in the limit. So our final answer m by l sine square theta capital L cube by 3. That means for an answer we are getting 1 l will cancel out, 1/3 m capital L square sin square theta. Thank you.